Professor Alan Whitfield walked through the physics department hallway at Harvard University. His polished shoes made loud clicking sounds on the marble floor. He had taught at this famous school for 15 years, and everyone knew he was important. Students moved out of his way as he passed, holding their books tightly. They all knew Professor Whitfield was very smart but also very harsh to students he thought were not clever enough. That afternoon, as students came into his advanced theoretical physics class, Professor Whitfield noticed someone new sitting in the back row. She was a young woman with reddish-brown hair tied back in a simple ponytail. She wore plain jeans and an old sweater that looked worn out. She did not look like his usual Harvard students who often wore expensive clothes. "You there, Professor?" Whitfield called out, pointing at her with his laser pointer. "This is Advanced Theoretical Physics 507. I do not think I have seen you on my list of students." The room became very quiet. Everyone turned to look at the young woman. "I am not enrolled, sir," she said in a steady voice despite all the attention. "My father works as a custodian here. I was just hoping to sit in if that is all right." Professor Whitfield raised his eyebrows high above his glasses. He smiled, but not in a friendly way. "The janitor's daughter wants to learn theoretical physics," he said with a cold voice that made several students feel uncomfortable in their seats. "How cute. Well, Ms. Mason, Olivia Mason. Well, Ms. Mason, this is not a community college. We do not let just anyone sit in on classes, especially not classes that need years of advanced math knowledge first." Olivia did not move. "I understand the math requirements, Professor." Professor Whitfield laughed and turned to his class with a look of disbelief. "You understand non-Euclidean geometry and tensor calculus? Tell me, where did you study? The cleaning closet between your father's mopping jobs?" A few students laughed, nervously. Most looked down at their desks, feeling awkward. "I study on my own," Olivia replied, her cheeks turning red but her eyes staying steady. "I have worked through Chandrasekhar's principles and Green's string theory books." The professor's smile changed to annoyance. "Ms. Mason, I have 60 students who earned their spots here through years of hard academic work. They do not need distractions from someone pretending to be a physicist." He turned toward the whiteboard, dismissing her. "If you want to learn physics, I suggest starting with a basic course at your local community college. Now, if you do not mind." Olivia stood up slowly, picking up her notebook. But instead of walking toward the door, she moved toward the front of the classroom. "Professor," she said quietly, "there is an error in your quantum field equation." The classroom became completely silent. Professor Whitfield turned around slowly, his face turning bright red. The equation behind him covered almost the whole whiteboard. It was a complex maze of symbols showing the newest ideas in theoretical physics research. This work represented his whole career, the result of decades spent trying to understand the universe's deepest secrets. "Excuse me," he said, his voice dangerously quiet. Olivia stood at the bottom of the classroom steps, holding her notebook against her chest. Even though she was clearly nervous, she did not back down. "Your approach to quantum gravity integration," she said, pointing to the right side of the huge equation. "You are using a standard Hamiltonian operator, but it creates a problem when applied to curved spacetime." The silence in the room grew deeper. Students looked at each other, some confused, others fascinated by this unusual scene happening in front of them. Professor Whitfield adjusted his glasses, pressing his lips into a thin line. "Perhaps you misunderstood, Ms. Mason. This equation represents a breakthrough in bringing together quantum mechanics and general relativity. Right now, the top scientists at CERN and MIT are reviewing it." "I understand that, sir," Olivia replied, her voice growing more confident. "But the math foundation still relies on traditional quantum field theory ideas that do not work at the Planck scale, may I?" She gestured toward the whiteboard. The professor laughed sharply and dismissively. "By all means," he said with fake politeness, holding out the marker to her. "Show Harvard's physics department how a janitor's daughter has solved the problem that has confused Nobel Prize winners for generations." Olivia took the marker, her hand steady. The eyes of 60 highly competitive, brilliant students followed her as she approached the whiteboard. Professor Whitfield crossed his arms, a smirk on his face as he prepared to watch her embarrass herself. For a moment, Olivia simply studied the sprawling equation, her eyes moving carefully across the variables and operators. Then, without erasing the professor's work, she began writing in a small empty section of the board. Her hand moved with surprising speed and confidence. New symbols appeared, unusual structures and operators that caused several graduate students in the front row to lean forward with sudden interest. She was not just making small changes, she was introducing a completely new mathematical framework. After 5 minutes of writing without stopping, she stepped back. What she had created was not just a correction, it was an elegant new way of thinking that somehow kept Whitfield's main ideas while transforming the mathematical foundation. If we substitute a quantum algebraic field operator here, she explained, pointing to her additions, and introduce this topological transform to handle n-dimensional branes, the singularity problem fixes itself. The equations stay consistent at all scales. Professor Whitfield stared at her work, his expression frozen somewhere between shock and disbelief. He stepped closer to the board, examining her notations with growing intensity. "That is," he began, then fell silent, calculating, quickly in his head, "That is not standard mathematical notation." "No," Olivia agreed. "It is something I have been developing, a mix of quantum algebra and geometric topology." One of the graduate students in the front row, a young man named Peter Holloway who had been silently following her work, suddenly spoke up. "Professor, I think she is right. This approach completely avoids the Lindemann paradox." The room burst into excited whispers. Professor Whitfield stood still, staring at the board with his mouth slightly open. In just 5 minutes, this unknown young woman had transformed his life's work into something both simpler and more profound. And in that moment, everyone in the room knew they were witnessing something extraordinary. The emergence of a brilliant, new mind that would change the course of theoretical physics forever. The next day, news about what happened in Professor Whitfield's classroom spread quickly throughout Harvard University. Students talked about the janitor's daughter, who had corrected the famous professor's equation. Some people recorded videos of the event on their phones, and these videos were shared among science students across campus. Professor Whitfield canceled all his classes that day. He stayed in his office from early morning, working through Olivia's mathematical corrections again and again. His desk was covered with papers full of equations and notes. He had not slept all night, trying to understand the new mathematical language Olivia had created. Around noon, there was a knock on his office door. Dean Charlotte Warren entered, carrying a folder in her hands. She was the head of the science department and rarely visited professors' offices unless something important had happened. "Alan," she said, looking at the mess of papers on his desk, "I heard about what happened yesterday. The whole science department is talking about it." Professor Whitfield took off his glasses and rubbed his tired eyes. "It is incredible, Charlotte. This young woman has developed a completely new way to solve the quantum gravity problem. I have been checking her work all night. It is valid. Not just valid, it is brilliant." Dean Warren sat down across from him. "I looked into her background," she said, opening the folder. "Olivia Mason, age 20. Her father, Greg Mason, has worked as a janitor here for 18 years. She never attended college. In fact, she barely finished high school, taking most classes online." "That is impossible," Professor Whitfield said, pointing to his calculations. "What she did yesterday requires understanding beyond PhD-level physics. Nobody could teach themselves this." "Apparently she could," Dean Warren replied. "I have asked her and her father to come in today. They should be here soon." As if on cue, there was another knock on the door. When Dean Warren called, "Come in," Olivia entered, followed by a tall man in a dark blue maintenance uniform. Greg Mason had the same reddish-brown hair as his daughter, but his was starting to turn gray. His hands were rough from years of physical work, and he looked nervous standing in the professor's office. "Ms. Mason, Mr. Mason, please sit down," Dean Warren said, pointing to the chairs. They sat down, and Greg put his hand protectively on his daughter's shoulder. Olivia looked directly at Professor Whitfield without fear or anger, just waiting to hear what he had to say. "Ms. Mason," Professor Whitfield began, his voice much softer than in the classroom yesterday, "I have spent all night reviewing your mathematical approach. I need to know, where did you learn this? Who taught you? Greg Mason spoke up before his daughter could answer. Nobody taught her, Professor. Olivia has always been special. When she was just 3 years old, she could count to 1,000 and do simple addition. By 5, she was solving math problems I could not understand. Dad brought me to work sometimes when I was younger, Olivia explained. While he cleaned the university buildings, I would go to the library. The librarians got to know me and let me read whatever I wanted. I read everything I could find on physics and mathematics. But reading is one thing, Professor Whitfield said. Creating an entirely new mathematical framework is something else entirely. Olivia shrugged. The traditional math did not work for what I was trying to understand, so I had to make something that did. Dean Warren and Professor Whitfield exchanged looks of amazement. Olivia, Dean Warren said gently, do you realize what you have accomplished? Professor Whitfield's equation represents years of work by some of the world's top physicists. What you did yesterday was not just correct an error. You may have solved one of the biggest problems in modern physics. Greg Mason looked confused. What does this mean? He asked, looking between the dean and the professor. Professor Whitfield leaned forward. Mr. Mason, your daughter has potentially bridged the gap between quantum mechanics and general relativity, two areas of physics that have been impossible to connect for nearly a century. If her approach is correct, and I believe it is, she has made a discovery worthy of a Nobel Prize. Greg's eyes widened in shock. Olivia remained calm, though her cheeks turned slightly pink at the praise. We would like to offer Olivia a place at Harvard, Dean Warren continued. A full scholarship to study physics with special permission to work directly with our research team. A scholarship? Greg asked, his voice filled with disbelief. To Harvard? For my Olivia? Yes, Professor Whitfield said. And more than that, I would like to work with her, to develop this mathematical framework further. With your permission, I would like to co-author a paper with Olivia, introducing her work to the scientific community. Olivia's calm expression finally broke into a small smile. You want to work with me? Yesterday you wanted me to leave your classroom. Professor Whitfield looked embarrassed. Yes, and I was wrong. I made assumptions based on your background, not your abilities. That was unprofessional and unkind of me. I am sorry. Dean Warren pulled a paper from her folder. There is something else. The International Science Foundation has a special grant for exceptional discoveries. After seeing the video from yesterday's class, they have expressed interest in funding Olivia's research. Greg Mason put his hand over his mouth in shock. This cannot be real, he whispered. It is very real, Mr. Mason, Professor Whitfield assured him. Your daughter has a mind that comes along perhaps once in a generation. While the adults continued talking, Olivia stood up and walked to the whiteboard in Professor Whitfield's office. Without asking permission, she picked up a marker and began writing a new set of equations. The room fell silent as they watched her work. Her hand moved quickly and confidently across the board, creating complex symbols and connections that even Professor Whitfield struggled to follow in real time. When she finished, she stepped back. This is the next step, she said simply. If we apply my framework to the cosmic inflation problem, we might be able to explain dark energy distribution. Professor Whitfield stood up and approached the board, studying her new equations with growing excitement. This is revolutionary, he said, his voice barely above a whisper. Dean Warren looked from the incomprehensible equations to the young woman who had written them. Olivia, she said, I think you are about to change our understanding of the universe. Greg Mason watched his daughter with tears in his eyes, overwhelmed with pride. The janitor's daughter, who had grown up in a small apartment and studied in stolen moments while he cleaned floors, was now standing as an equal with Harvard professors. And this was just the beginning of her journey. 6 months had passed since Olivia Mason had shown her mathematical genius in Professor Whitfield's classroom. Her life had changed completely in that short time. She now had a small office in the physics department at Harvard University, right next to Professor Whitfield's larger one. She was both a special student and a research partner. a situation that had never happened before at the famous school. The science world had reacted strongly to her first published paper. Some older scientists did not believe that a young woman, with no formal education, could have created such advanced mathematics. Others recognized her brilliance immediately and wanted to work with her. Either way, Olivia Mason had become famous in the world of physics. On this particular morning, Olivia sat in her office, drawing complex diagrams on a large digital tablet. Her father, Greg Mason, still worked as a janitor at Harvard, but now he wore his uniform with pride. His daughter had become one of the most talked-about scientists in the country. There was a knock on her office door, and Professor Whitfield entered. In the past 6 months, he had changed from her harshest critic to her strongest supporter. He carried a letter in his hand and looked excited. "Olivia, it came," he said, handing her the letter. "The National Science Foundation has approved our research grant, $5 million for 2 years. Olivia took the letter and read it quickly. "This means we can build the quantum simulator?" "Yes," Professor Whitfield nodded. "We can start ordering the equipment next week. But that is not all. Look at the second page." Olivia turned the page and her eyes widened. "They want us to present at the International Physics Conference in Tokyo." "Not just present," Professor Whitfield said, smiling. "They want you to be the keynote speaker. Olivia, this is a tremendous honor. Usually only senior scientists with decades of experience get asked to give the keynote address." Olivia put the letter down on her desk. Despite all the attention her work had received, she still lived simply. She wore plain clothes, kept her hair in the same simple ponytail, and spoke quietly. Success had not changed her personality. "Do not know if I can speak in front of thousands of people," she said honestly. "You will do fine," Professor Whitfield assured her. "Just explain your work like you explain it to me. The mathematics speaks for itself." Just then, Dean Warren appeared at the door. "Ah, I see Alan has given you the good news," she said. "But there is something else you should know. There are some visitors here to see you. They are waiting in the conference room." "Visitors?" Olivia asked. "Who?" "Representatives from the United States government," Dean Warren replied, her expression serious. "From NASA and the Department of Defense. They say it is important." Professor Whitfield and Olivia followed Dean Warren to the large conference room. Inside, 5 people in formal business clothes sat around the table. A tall woman with short gray hair stood up as they entered. "Dr. Mason, I am Dr. Helen Rogers from NASA's Theoretical Physics Division," she said, extending her hand. "These are my colleagues from various government departments. We need to speak with you about your recent paper on quantum field dynamics and curved spacetime." Olivia shook her hand, feeling confused. "I am not Dr. Mason yet. I am still a student." "Dr." Rogers smiled. "Harvard has fast-tracked your doctoral status considering your contributions to the field. The paperwork will be finalized next month. Please sit down," said a serious-looking man in a military uniform. "I am General Frank Wilson. What we are about to tell you is classified information." Everyone sat around the table. General Wilson pressed a button on a small device and the windows of the conference room turned dark. 3 days ago, our deep space monitoring station in New Mexico detected something unusual, Dr. Rogers began. "A distortion in spacetime near the orbit of Jupiter. At first, we thought it was an instrument error, but multiple stations have confirmed it." She placed a tablet computer on the table and slid it toward Olivia. On the screen was a swirling pattern of light against the blackness of space. Even in the simple image, Olivia could see that something strange was happening to the fabric of reality itself. "This looks like a quantum field disruption," Olivia said, studying the image carefully. "But on a macro scale, that should not be possible." "Exactly," Dr. Rogers nodded. "According to all known physics, this should not exist. But it does, and it is growing." Professor Whitfield leaned forward to look at the image. "What do your scientists think it is?" General Wilson spoke up. "Our team believes it could be a naturally occurring phenomenon we have never observed before. But there is another theory." He paused, looking uncomfortable. "Some think it might be artificial," Dr. Rogers finished for him. created by an intelligence. You mean aliens? Professor Whitfield asked, his voice showing his disbelief. We do not know, Dr. Rogers replied honestly, but what we do know is that the mathematical pattern of this distortion shares remarkable similarities with the new quantum field equations published by Ms. Mason 3 months ago. All eyes turned to Olivia. She continued studying the image, her mind working quickly through the possibilities. The quantum resonance patterns do match my equations, she said finally. But I was describing theoretical interactions at the subatomic level. This is happening on a cosmic scale. That is why we are here, Dr. Rogers explained. We need your help to understand this phenomenon. If it continues to grow, it could potentially affect Earth's communications, satellites, or worse. General, Wilson leaned forward. Ms. Mason, we are putting together a special research team to study this anomaly. We want you to lead it. Olivia looked up in surprise. Me? But there must be scientists with much more experience, none who understand the mathematics behind this phenomenon as well as you do, Dr. Rogers interrupted. This is your theoretical framework coming to life in ways nobody predicted. You are the best person to help us understand what is happening. Professor Whitfield put his hand on Olivia's shoulder. You do not have to decide right now. This is a lot to take in. Actually, time is a factor, General Wilson said firmly. The anomaly is growing exponentially. We have set up a research facility in Colorado. We need Ms. Mason there as soon as possible. Olivia looked at the swirling pattern. On the screen again, something about it seemed almost familiar, like a message written in a language only she could read. I will help, she said quietly. When do we leave? Today, if possible, Dr. Rogers replied. A government plane is waiting at the airport. Dean, Warren looked concerned. This is very sudden. Olivia is still our student. This is a matter of national security, General Wilson cut in. Possibly global security. Olivia looked at Professor Whitfield. What do you think I should do? The professor smiled sadly. I think you have moved beyond what I can teach you, Olivia. The universe itself seems to be responding to your mathematics. You should go where your mind is needed most. Olivia nodded and turned back to Dr. Rogers. I need to tell my father where I'm going, and I will need my research notes. Of course, Dr. Rogers agreed. Pack whatever you need, but remember, everything about this project is classified from now on. As the meeting ended, Olivia stood at the window, looking out at Harvard Yard where students walked between classes, unaware that something extraordinary was happening in space. The janitor's daughter, who had shocked a classroom 6 months ago, was now being called to help solve a cosmic mystery that might change humanity's understanding of the universe forever. 2 weeks had passed since Olivia Mason arrived at the secret research facility in Colorado. The complex was built into the side of a mountain, with most of its structures hidden underground. Here, the best scientists from NASA, the military, and various universities worked together to understand the strange phenomenon near Jupiter. Olivia had her own laboratory with the most advanced equipment available. The walls were covered with whiteboards filled with her unique mathematical symbols. Computer screens displayed the growing anomaly in space, updated with real-time data from telescopes around the world. Dr. Helen Rogers from NASA entered the lab, carrying 2 cups of coffee. She had become Olivia's main contact and supporter at the facility. Any progress? Dr. Rogers asked, handing 1 cup to Olivia. Olivia took the coffee but barely noticed it. She was staring at the main screen, where the swirling pattern of the anomaly pulsed and shifted. It is not random, Olivia said quietly. I thought it was at first, but there is a pattern. Look here. She pointed to a sequence of numbers on her computer. These quantum fluctuations repeat every 137 seconds exactly. That is the fine structure constant, Dr. Rogers noted with surprise. 1 divided by 137. That cannot be a coincidence. No, Olivia agreed. And there is more. The pattern of the space-time distortion itself, it follows mathematical rules. My rules. She walked to one of her whiteboards and pointed to a complex equation. This is from my paper 3 months ago, and this, she pointed to another screen. showing the anomaly structure, is almost exactly the same pattern. Dr. Rogers stared at the comparison. Are you suggesting something, or someone is using your mathematical framework to create this phenomenon? Before Olivia could answer, the door opened and General Wilson walked in with Professor Whitfield. The professor had been invited to join the research team a week ago, after insisting he could help Olivia with her work. We have new information, General Wilson announced. Our deep space probe reached the edge of the anomaly an hour ago. The data is still coming in. Everyone moved to the main conference table where a large screen showed the probe's video feed. The image showed the blackness of space with Jupiter visible in the distance. At the edge of the frame was the anomaly, a swirling, shifting area where space itself seemed to bend and fold. The probe will enter the distortion in approximately 5 minutes, said a technician who sat at a computer. They watched in silence as the probe moved closer to the edge of the strange phenomenon. The video feed began to show static and distortion. We are losing signal, the technician reported. Expected, Olivia said calmly. The quantum field disruption would interfere with normal transmission. Suddenly, the video cleared again, but what they saw made everyone gasp. The probe had passed through the edge of the anomaly, and on the other side was not empty space, but something else entirely. The screen showed what looked like a massive structure, a geometric pattern of lights, and dark materials that stretched as far as the probe's cameras could see. What is that? General Wilson demanded. Is that a space station? It appears to be artificial, Dr. Rogers said, her voice filled with awe. Constructed. Olivia stepped closer to the screen, her eyes wide. The structure. It is a physical representation of the quantum field equations. Someone built this. Someone? Professor Whitfield repeated. You mean, not human, Olivia finished for him. The scale is too vast, the complexity too great. This was built by an intelligence far beyond our own. As they watched, the probe continued to move through the strange environment. The structure seemed to respond to its presence, parts of it shifting and rearranging. It is adaptive, Olivia observed, responding to the probe's quantum signature. Suddenly, the video feed showed a new development. A smaller object had detached from the main structure and was moving toward the probe. Is it attacking? General Wilson asked, his voice tense. I do not think so, Olivia replied. The approach pattern is cautious, not aggressive. The object came closer to the probe's camera. It was unlike any spacecraft humans had ever designed, a complex geometric shape that seemed to shift and change. As it moved, then something completely unexpected happened. Words appeared on the screen, overlaid on the video feed. Greetings, Olivia Mason, we have been waiting. The room fell completely silent. Everyone turned to look at Olivia, whose face had gone pale. They know your name? Professor Whitfield whispered. How is that possible? Olivia stared at the screen, her mind racing. My papers, my equations, they must have been monitoring our scientific communications somehow. This is beyond anything we imagined, Dr. Rogers said. Not just extraterrestrial intelligence, but extraterrestrials who have been watching us and specifically identified you. General Wilson turned to his communications officer. Get the president on the line, now. While the military personnel rushed to secure communications, Olivia remained fixed on the screen. More text appeared. Your mathematical framework bridges our understanding. We wish to communicate. Will you respond? The technician looked up from his console. They have established a direct link to our systems. We can send a message back if we choose to. This is a matter of global security, General Wilson insisted. We need authorization before responding. Olivia turned to face him. With respect, General, they are not asking to speak with our government. They are asking to speak with me. This is unprecedented, Dr. Rogers said. First contact with an alien intelligence, and they want to communicate with a specific human. Professor Whitfield put his hand on Olivia's shoulder. It makes a strange kind of sense. Olivia's mathematics may be the first human creation that their intelligence could recognize as advanced communication. Her equations speak a universal language. Olivia looked back at the screen, where the message still waited for a response. I need to answer them. The president will decide, General Wilson began. By the time we get authorization, they might. Give up trying to communicate, Olivia interrupted. This is too important to delay. Before anyone could stop her, Olivia moved to the technician's console. May I? She asked. The young man looked at General Wilson, who after a moment of hesitation nodded. Olivia began typing. This is Olivia Mason. I am receiving your communication. How did you find me? The response came almost immediately. Your mathematics reached across space. The patterns of your thought resonated with our own. We have been searching for minds like yours throughout the galaxy. We have much to share. As the implications of these words sank in, the room remained utterly silent. The janitor's daughter, once mocked in a Harvard classroom, was now humanity's first point of contact with an advanced alien civilization, and whatever happened next would change the course of human history forever. 3 days had passed since the first contact with the alien intelligence. The secret facility in Colorado had transformed into the center of the most important event in human history. Government officials, top scientists, and military leaders from around the world had gathered there. Despite all these important people, one person remained at the center of everything. Olivia Mason, the janitor's daughter. Olivia now worked in a special communication room set up just for her. The walls were covered with screens showing data from the anomaly near Jupiter. In the center was a large computer system dedicated to her conversations with the aliens, who called themselves the Axiom. Greg Mason, Olivia's father, had been brought to the facility as well. He sat in a corner of the room, watching his daughter with a mixture of pride and worry. His life as a simple janitor seemed far away now. Professor Whitfield entered the room, carrying 2 cups of coffee. He handed one to Greg and stood beside him. How is she doing? The professor asked quietly. Greg shook his head in amazement. She has been talking with them for 18 hours straight. She does not seem tired at all. They watched as Olivia typed rapidly on her keyboard, her eyes fixed on the main screen where the Axiom's messages appeared. The aliens communicated, mainly through text and mathematical symbols, though occasionally they sent images of their world and technology. Dr. Rogers approached Olivia with a sandwich and a bottle of water. You need to eat something, she insisted. Olivia barely noticed the food. They are showing me their propulsion system, she said, pointing to a complex diagram on one of the screens. It uses the same quantum principles I developed in my equations, but they have applied it on a scale we never imagined. What are they saying about the anomaly? General Wilson asked, joining the group. Is it a threat to Earth? Olivia shook her head. No. It is a bridge, what they call a quantum gateway. They created it as a way to communicate with us. They have been searching for civilizations that understand certain mathematical principles. My papers caught their attention. So they created a wormhole just to talk to us? Dr. Rogers asked in disbelief. Not exactly, Olivia replied. The gateway is more than just for communication. They want to meet us in person. The room fell silent at this statement. Meet us? General Wilson repeated. You mean they want to come to Earth? No, Olivia said. They have invited us to visit them. Specifically, they have invited me. Professor Whitfield stepped forward. That is out of the question. We know nothing about them or their intentions. Olivia turned to face the group. For the first time in days, she looked away from her screens. I have been speaking with them, constantly. They have shared their history, their science, their philosophy. They are not a threat. They are teachers. Teachers? Greg asked, speaking for the first time. Olivia nodded, her eyes bright with excitement. Yes, Dad. They say humanity is at a turning point. Our understanding of physics is just reaching the level where we can join a community of intelligent species across our galaxy. My mathematical work was like a signal to them that we were ready. General Wilson crossed his arms. Even if what you say is true, we cannot just send you through some space anomaly to meet aliens we know nothing about. I believe we can trust them. Olivia insisted. And they have shared designs for a small ship that could safely travel through the gateway. They say the journey would take only minutes from our perspective. Dr. Rogers examined the schematics on one of the screens. These designs incorporate Olivia's quantum field equations, but with modifications that actually solve several problems our engineers have been struggling with. If these work the way they claim, this technology is decades ahead of anything we have. We could build it, one of the NASA engineers said, studying the designs. With their specifications, we could construct a small vessel in about 2 weeks. This is moving too quickly, General Wilson protested. The security implications alone, General, Olivia interrupted, her voice firm despite her usual quiet manner. The Axiom have shared more advanced technology with us in 3 days than we might have developed in a century. They have shown us how to create clean energy that could end pollution. They have offered medical knowledge that could cure diseases we thought were hopeless. All they ask in return is to meet the human who created the mathematics that reached them. President Laura Evans, who had been listening quietly from the back of the room, finally spoke. Ms. Mason, do you want to go? All eyes turned to the president, then back to Olivia. Yes, Madam President, Olivia answered without hesitation. I believe this is why I created those equations in the first place. Somehow I always felt I was working towards something bigger than I understood. The president nodded slowly. Then we will build the ship, but you will not go alone. We will assemble a small team of scientists and security personnel to accompany you. Greg Mason stood up suddenly. If my daughter is going to another world, I am going with her. Dad, no, Olivia protested. It could be dangerous. Greg smiled at her. For 18 years I cleaned floors so you could have enough to eat and a safe place to study. I am not letting you travel across space without me. Olivia's eyes filled with tears. She crossed the room and hugged her father tightly. President Evans turned to General Wilson. Begin preparations immediately. This will be humanity's first official diplomatic mission beyond our solar system. 2 weeks later, a small ship called the Pioneer stood ready in a launch facility hidden deep in the desert. Built according to the Axiom specifications, it looked unlike any spacecraft humans had designed before. Its hull was made of a new material that shimmered with a faint blue light, and instead of conventional engines, it had quantum field generators based on Olivia's equations. A small group had gathered to see off the expedition team. Olivia stood at the front of the group of 6 people who would make the journey. Herself, her father, Greg, Professor Whitfield, who had insisted on coming, Dr. Rogers from NASA, and 2 security officers with scientific backgrounds. As they prepared to board, President Evans addressed them. You carry with you the hopes and dreams of all humanity. What you discover may change our world forever. Olivia looked at her father, then at the ship that would take them through the gateway. From a classroom at Harvard to the edge of the solar system, the janitor's daughter was about to make history. We are ready, she said simply. And with those words, humanity prepared to take its first step into a larger universe.